Okay, so parametric differentiation. So if we want to find dy by dx, we can do dy by dt times dt by dx. So our first question. Find the gradient at the point t equals 2 on the curve x equals t cubed plus t and y equals t squared plus 1. So we have x equals t cubed plus t, and we're going to differentiate our x with respect to t. So we'll get 3t squared plus 1. We have y then is t squared plus 1. So now we're going to differentiate y with respect to t, and we get 2t. So our dy by dx is dy by dt, which is 2t, times dt by dx. So it's 1 over this part here. So we can write that as 2t over 3t squared plus 1. And then we want to find the gradient when t is 2. So when t is 2, dy by dx is going to be 2 times 2 over 3 times 2 squared plus 1. So we get 4 on the top and 13 on the bottom. Number 2, then find the equation of the tangent to the curve x equals 1 plus t and y equals 1 over t at the point when t equals 1. So if x equals 1 plus t dx by dt, differentiate 1, we get 0, differentiate t, we get 1. All right, y as t to the power minus 1. Differentiate y with respect to t, and we get minus t to the power of minus 2. So we get minus 1 over t squared. So then dy by dx equals dy by dt times dt by dx. So 1 over 1, which is just 1. Okay, so we have dy by dx. We want to find then the equation of the tangent. So when t is 1, we need to find the x value, the y value, and the gradient. So x is going to be 1 plus 1, so that's 2. Y is going to be 1 over 1, so that's 1. And dy by dx is minus 1 over 1 squared, so that's minus 1. Finding the equation then. These are y minus y1 equals m upon x minus x1. So our y value was 1, our gradient was minus 1, and our x value was 2. So multiply it out and tidy it up. We get y equals minus x plus 3. Our third one then, x equals t plus 1, y equals t cubed, and we want to find dy by dx and d2y by dx squared. So differentiate our x with respect to t, and we get 1. Differentiate our y with respect to t, and we get 3t squared. So dy by dx is dy by dt times dt by dx. So that's 3t squared by 1 over 1. So that just gives us 3t squared. Now to get d2y by dx squared, well, what we want to do is we want to differentiate dy by dx with respect to x, but we can't do that because dy by dx is in terms of t, so we have to differentiate dy by dx with respect to t. But to keep our whole thing right, we'll have to then multiply by dt by dx. The easiest way to think about it, those dt's would cancel. So we're differentiating dy by dx, which is our 3t squared, with respect to t, and we get 6t. We're multiplying by dt over dx, which is 1 over 1. So we get 6t. Fourth one then, x equals 4 minus t cubed, y equals t squared minus 2t. Find dy by dx and d2y by dx squared. So first of all, we're going to differentiate x with respect to t, and we get minus 3t squared. I'm going to differentiate y with respect to t, and I get 2t minus 2. So dy by dx is dy by dt times dt by dx. So that's 2t minus 2 times 1 over dx by dt. So that's 1 over minus 3t squared. So that would be minus 2t minus 2 over 3 squared, and you can tidy that up a couple of different ways. So then to get d2y by dx squared, we'd want to differentiate dy by dx again with respect to x, but we can't because there's t's in it. So we'll have to differentiate dy by dx with respect to t, and then to keep it right, times it by dt by dx. So I'm just going to tidy our dy by dx up a bit and multiply this minus in. So that's 2 minus 2t over 3t squared, and dt by dx is 1 minus 3t squared. So now we're differentiating this fraction or quotient, so we'll have to use the quotient rule. So the quotient rule, then we need to differentiate that fraction. So it's the bottom bit times differentiate the top minus the top bit times the differential of the bottom all over the bottom bit squared, and then we still ever multiply by 1 over minus 3t squared. Now it's just the tidying it up, and I know you love tidying up all the algebra. So the first few bits should be straightforward enough. It's just multiplying out the brackets and then simplifying. Right, there's different steps you could take here. I'm going to take out minus 3t. So I'm going to be left in the bracket with minus 2t plus 4. And I'm taking that out so I can cancel. The minus 3 and the minus 3 will cancel out, and the t will cancel. So we have minus 2t plus 4 over 9t to the power of 5. I would prefer to write it just with the 4 minus 2t on the top, but either way is fine.